This video on capacity is the final video in a series on measurement at this stage. In this video, we'll look at a reminder of what volume is, then we'll explore what capacity is before looking at the volume-capacity connection, followed by examples where we convert units to capacity and calculate capacity. You may recall from the video on volume units, volume of prisms and cylinders, that volume is a measure of the space or cubic units occupied by a three-dimensional object or solid. Common units for measuring volume are cubic millimeters, cubic centimeters, and cubic meters. If you need a further explanation on this, please refer to the video on volume units, volume of prisms, and volume of cylinders. Capacity is the volume of fluid or gas that a container can hold. Common units for measuring capacity are megaliter, kiloliter, liter, and milliliter. Here we have a hollow container. If we fill the container with a liquid or gas, the volume of the container would be specified in capacity units. Unless we are converting between units of capacity, we need to calculate an object or solid's volume first to calculate its capacity. For containers holding liquids and gases, we do not specify their volume in cubic centimeters or cubic meters. A container's size is specified in centimeters or meters cubed, but how much liquid or gas the container holds is specified in milliliters or liters. Remember this, volume is how big a container is, but capacity is how much the container can hold. So we have 1 cubic centimeter, and that's equivalent to 1 milliliter. That's given by the 3 dashes here, which is similar to an equal sign. 1,000 cubic centimeters is equivalent to 1 liter. 1 cubic meter is equivalent to 1 kiloliter. 1 cubic meter is equivalent to 1,000 liters. Here we have a 1 centimeter by 1 centimeter by 1 centimeter cube. The volume of the cube is 1 centimeter cubed, which is equivalent to 1 milliliter. Here we have a chart that helps us convert between capacity units. Let's look at a couple of examples. If we have 7 megaliters, how many liters is that? Using our chart, we can identify that we're going to have to times it by 1,000 and then times it by 1,000 to get from megaliters on the left to liters 2 from the left. So we times it by 1,000, which is 1 million, and we get 7 megaliters is equivalent to or equal to 7 million liters. We have 1,500 milliliters. How many liters is that? Now we're starting on the right and we work our way backwards to liters, so we divide by 1,000. So we get 1,500 milliliters is equal to 1.5 liters. Let's look at the capacity of a cone. In order to find the capacity of the cone, first we have to work out the volume. So the volume of a cone is given by 1/3 the area of the base. In this case, it's the top times the perpendicular height. Now we have our cone with some measurements. So we substitute in our known values, and we know the formula for the area of a circle is pi r squared. So we've got 1/3 pi r squared times the perpendicular height. And we substitute in our values. So we have a radius of 10 centimeters and a perpendicular height of 15 centimeters. And we evaluate, and we get the volume is 500 pi centimeters cubed, which is 1,570.8 centimeters cubed. Now we have our volume, we can convert it to capacity. So we know 1 cubic centimeter is equivalent to 1 milliliter. Therefore, 1,570.8 centimeters cubed is equivalent to 1,570.8 milliliters, and therefore the capacity of this cone is 1,570.8 milliliters. In the previous videos, we calculated the volume of these solids. Let's assume that these solids all have the same volume. So we've got the volume of the cylinder, pyramid, and sphere is 1,570.8 centimeters cubed. This is equivalent to 1,570.8 milliliters. So the capacity is 1,570.8 milliliters of all of these solids here. How many liters is it? To convert to liters, we looked at that previously. We've got to divide by 1,000. And we get the capacity in liters of these solids is 1.57 0.08 litres. A tin can has a diameter of 72 millimeters and a height of 163 millimeters. How many milliliters of juice can it hold? It's always a good idea to draw the problem first and then label your diagram with the measurements provided. This is a good starting point. Now we have a cylinder and we know that we need to work out the volume of the cylinder first. So the formula for the volume of the cylinder is pi r squared times the height, which is the area of the base or the cross section times the perpendicular height. And there we go. And we substitute in our known values. Please note they've given us the diameter of the can. The formula for the volume of a cylinder is we need the radius of the cross section. So we need to divide the diameter by 2 in order to get the radius, and that's what we've done here. And now we can evaluate. So we square our 72 on 2 and we multiply 1296 by 163 and we get 211,248 pi millimeters cubed, or 663,655.16 millimeters cubed. Now they've asked us to work out how many milliliters. We know that 1 cubic centimeter is equivalent to 1 milliliter, but our volume is in millimeters cubed. So we're going to convert our millimeters cubed first to centimeters cubed. To do that, we divide by 10 to the power of 3, which is the same as dividing by 1000, or 10 times 10 times 10. And we get the volume in centimeters cubed is 663.7 centimeters cubed. And that's the equivalent to 675.87 milliliters. Therefore, the capacity of this juice can is 675.87 milliliters. That's how much juice it can hold. And this concludes the series on measurement. During this unit, we have covered in detail length units and perimeter or circumference, area units and area, volume units and volume, capacity units and capacity. I should point out that whilst Pythagoras' theorem is not explicitly part of the series, questions that require the use of Pythagoras are often woven into exercises to do with measurement. So it may be a good idea to look at the videos on Pythagoras as well when you're looking at these. Thanks everyone.